Hi class, welcome to this new video of tutorial 12 where together we will answer question 3 and question 4. Now let's have a look at question 3. You are asked to find the Laplace transform of these four functions. As a solution, right, let's find the Laplace transform of the first function f of t, right, which is equals to Laplace transform of t u t minus 1. So ut minus 1 is what we call a unit step function. Now, let me recall to your knowledge the two most formula from the Laplace transform table that we will use in this video. So the Laplace transform of exponential f of t is equal to f s minus a. This is called the first shift theorem. And then also exponential of ut minus a ft minus a, right, equals to e minus as f of s, right? So these are the main Laplace transform equation that we use in this to solve the question of this tutorial. So to therefore find the Laplace transform of this, right? What do you see? I see that I have tut minus 1. So I need to write this equation here on this form, right? So what will I do? I need to rewrite t here in such a way that I have t minus 1. So it will give me Laplace transform of t minus 1 plus 1, right, of ut minus 1. This will give me Laplace transform of ut minus 1 t minus 1, right, plus ut minus 1. So applying the linearity, I will have Laplace transform of ut minus 1 t minus 1 plus Laplace transform of ut minus 1. So we can see that I can put 1 here. So I can see that from this equation, I can directly apply this formula where a is minus 1. So um this will give me 1, right, over x squared e minus s, because you see here is t minus 1, but I find the inverse of t. I find the Laplace inverse of t because here is f of s, not f of s minus something. Okay, so I have this plus, here I have 1, right? So it will give me 1 over s because the inverse of Laplace, the transform Laplace, the Laplace transform of 1 is 1 over s. Then I have e minus s because I have a here is minus 1. So if we look at the second example quickly, we have the Laplace transform of ut pi minus pi over 2 cos t, right? So to rewrite this under this form, we need to rewrite cos t, right, in such a way that we have sin of t minus pi over 2 equal to minus cos t. So I can sub it in here, right, equals to, I can, yes, I have u t minus pi over 2 times sine t minus pi over 2. I have the minus here, right? And I can bring the minus out of the bracket, right, of u t minus pi over 2 sine t minus pi over 2, right? So this will give me minus, right? I can then apply directly this formula here, which I will have a exponential minus a exponent. So I will have the Laplace transform of sine t, right, which I know it will give me 1 over s squared plus 1 times e minus pi over 2s, because here a is pi over 2, and it's, yeah. So let's look at the third function. Find the Laplace transform of t minus 1 power 3 et ut minus 1. So I have this here, and then having this, I need to rewrite this equation in such a way that on this term also I have t minus 1. So how do I do that? I do that is t minus 1 power 3 et minus 1 plus 1 ut minus 1. So this is equal to the Laplace transform of t minus 1 power 3 ut minus 1 ut minus 1 times e power 1. So this is a constant. I can bring that out. Is e power 1 Laplace transform of ut minus 1 times t minus 1 power 3 ut minus 1. So I realize that this this is written in the form of the Laplace transform of exponential at if ft, which is equals to f minus s. So this therefore will give me, I have e1 here, right? And I already considered this as a f of t, right? My minus a, right? So this will give me e minus s times 3 factorial over s, 3, correct this thing here, sorry. So it will give me 3 factorial divided by um, 3 factorial, 3 factorial divided by s minus 1 power 4, right? So this will give me e1 minus s divided by s minus 1 power 4. Now, let's look at the fourth example, G, where I have to find the Laplace transform of f of t with f of t equals to 0t squared for 0 less or equal to t and t less than 5, and then I have t superior equal to 5. Now, once I have this, I have to write this function as a in terms of a unit step function, because that will help me to easily find the Laplace transform. So now this is the best form I got this way, t minus 5 plus 25, and all of this I multiply it by t minus 5. Now let me tell you why I had this, because it's also important to you to understand how to rewrite function as such, so that you will be able to answer questions during the exams or during the tutorial or the test. Now look, if t is if 0 is less or equal to t and t less than the 5, this will give me 0, right? This will give me 0. And if this is 0, everything, the function f of t is 0. Now, if t is superior to 5, the unit step function, if t is superior to 5, this unit step function will be equal to 1, right? Because if you go and check how we define the unit step function, you'll see this is if t is superior to 5 is equal to 1, and then you will realize that all this term here, if you apply the distribution law here, you'll see that all this term inside here will give you t squared. So we wrote it in a very nice way so that we can easily find the Laplace transform. So therefore, the Laplace transform therefore of f of t will simply be Laplace transform of t minus 5 square ut minus 5, right, plus 10 Laplace transform of t minus 5 u t minus 5, right, plus 25 times Laplace transform of ut minus 5. Okay, so having this, therefore, I can then directly have a this. So this will give me I have e minus 5s times, I find the Laplace transform of t squared. So I have 2s power 3, right, plus 10 times 1 over x squared, right, um, times e minus 5s plus 25 1 over s e minus 5s. So I can put the e minus 5s in bracket, right? I have 2s power 3 plus 10 over s squared plus 25 over s. So that is the Laplace transform of that function. Now, if we have a look on question 4, right? And then you have f of t is given as 1t if 0 is less than t less than 2, and if t is superior or equal to 2. So we need first to express this as a unit step function. And as I explained before, right, the best thing, the best thing to do, right, is to rewrite f of t as a unit step function. And this is how my logic drives me. I'll have t minus 2, right, plus 1, right, ut minus 2 plus 1. Okay, so this is how it works. Now, you realize that if t is in this interval here, right, the unit step function is 0. Yes. So if it's 0, it means that everything here will be 0. Then I'll be left with 1. So it's 1, it makes sense. However, if then the t is equal to 0, the unit step function will be 1, right? And if it is 1, it means that everything inside here will be t minus 1 plus 1 here, therefore it will be t. This 1 and 1 here will cancel, it will be t. So I have written it this way and keeps or preserve the integrity of the piecewise function. So therefore, this then will now lead me to the Laplace transform of f of t will be equal to, right, will be equal to Laplace transform of 1 plus t minus 2 ut minus 2, right, plus ut minus 2, right. So I have Laplace transform of 1 plus Laplace transform of t minus 2 ut minus 2 plus Laplace transform of ut minus 2. So this is 1 over s plus 1 over s squared e minus 2s plus 1 over s e minus 2s. So I can put this in factor to be 1 over s plus e minus 2s factor of 1 over s squared plus 1 over s. So this is the Laplace transform of my function. I hope that you will find this video useful for your